Good morning, friends. I am here again for my course, Aircraft Systems. The topic of today's class is Power Generation and Control. As you know, my name is Dr. Dwivedhi, Professor from Institute of Aeronautical Engineering, Hyderabad, India. In the pursuit of this course, I have completed my 8 lectures before. In my previous lectures, I have covered the main pillars of aircraft systems. We have divided these aircraft systems in 4 pillars. Like first one is aircraft structures or airframe systems. Second one is the vehicle system. Third one is this avionics system, and fourth one is a mission system. Here I am in the module 2. This module 2 is basically related to the aircraft electrical systems, firefighting systems, refrigeration and air conditioning systems and all. But first, it focuses on aircraft electrical system. Once we talk about the aircraft electrical system, power generation, how the power is developed and how the power is made available, these all things are very much essential, and how these powers to be controlled, these all required to be considered before we start any system operation. You know that most of the aircraft avionics, hydraulic systems, pumps, oil pumps, fluid pumps, fuel pumps, all things are running with the help of some motors. These motors are operated by the electrical power. Sometimes few pumps are also operated with the engine drive. The drive is taken from the engine and the pump is rotated by the gearbox arrangement. So we have to see that aircrafts are totally uninterrupted power supply is available, and also how this power is generated and how this power is distributed among all the aircraft systems which are used in the present day scenario. In today's class, I will be discussing about power generation and control in this direct current system, then alternating current system, then direct current generator, parallel operations. These all things I am going to discuss in today's this class. So, power generation and control. The primary element of power system controls are DC systems and AC systems. We can divide into 2 groups. One is the DC system, another is the AC system. So, how this DC system and AC systems are working? So, these are the voltage regulations. In DC system, we have to have voltage regulations, parallel operations, protection functions. So we need to do first voltage. How we can regulate a required voltage, that much is required for the aircraft. And then also we need a parallel operation. How this, if one is fail, how another system will work, and how both systems will work together, and how the protection, these things are protected, in which way, these are things we have to understand. Same way, in place of protection system, we have the supervisory system on the alternating current system. There are some devices which works as a supervisor for the alternating current. We also need to have the voltage regulations. The voltage should be as per the design of the component. Every component is designed for certain voltage. The generated power has to produce as per the given voltage. System also should be able to work parallelly. If one is failed, another has to take over, and aircraft should work as per the required standard. And supervisory function, it has to handle the supervised by some equipments. Now I will talk about the DC generation and the control. How this DC voltage are generated and how these things are. So if you see, the DC voltage will go like this, like this. It is a one circle. This is the DC. If you take the AC, just I am extending here. This is the AC. In AC, what will happen? It will go up, it will go down, it will go up, it will go down, and so on. So it is a AC, alternating current. So in this, fluctuation is both the direction. It is a plus direction and this is the minus. And here only in the plus direction. Normally, if it is a single phase, it will be like this. If it is a multi-phase, it will go like this, and if some more are there, it will go like this, and so it is acting as a smooth. Comparing to the AC, DC, the voltage of the DC is very smooth, but here it is in the both direction, plus and minus, it is vibrating like a vibration. But here it is only in the one direction, that is 2 in the plus direction. So that is the advantage of this. The fluctuation of the voltage and the current is limited, not like AC. So how we do the voltage regulation on DC? DC generation is by means of shunt wound self-exciting machine as given in figure. So here this you can see there is a DC generator, and this is DC generator, and here we have one voltage increase and the decrease. It is a resistance here, and this resistance will vary plus or the minus as per the requirement of the system. And here this voltage are generated by help of magnets, okay, and coils. These are the magnets here, number of magnets, north, south, north, south, okay, and these are the coils, and this is the shaft here. So as and when we rotate this shaft, and there is a change in magnetic flux. Due to change in magnetic flux, the current is generated inside this each coil, and this is taken out from here, and this will go here, and this will pass from here, and there is a voltage regulator. This will increase. If you shift this thing upward, it will increase, and if you make downwards, the voltage is going to decrease. Okay, so that is the benefit of this type of regulation. It is very simple regulation, and as per the required voltage, we can obtain the voltage as much we want. Now, what is the meaning of parallel operation? As I have shown you that the DC systems, power generation and its control. So how? So first voltage regulation, then parallel operation and the protection. So this voltage regulation I have covered. Now what is the parallel operation? In multi-engine aircraft, each will have own generator, and in this situation, it is desirable that no break or uninterrupted power is provided in cases of engine or generator failure. You know that nowadays we have two engine. You can say this is the left engine and this is the right engine. Here both side one generators are fitted, and these generators G, I am writing here G, GL and GR, they are generating some power. These power should work parallelly. In case of anything failure, if this system is failed left, this right will start supplying power to the different loads. Okay, so The parallel operation means uninterrupted power should be given at any case if the both generators of left and right are working, or if anyone is failed, the working generator has to take over and it has to supply sufficient power uninterrupted without any problem to the different systems of the aircraft, and every system has to work as per the required standard of the flight. So in multi-engine aircraft, each will have own generator, and in this situation, it is desirable that no break or uninterrupted power is provided in case of engine or generator failure. A number of sensitive aircraft instruments and navigation devices which comprise some of the electrical loads may be disturbed and may need to be restarted or re-initialized following a power interruption. So what is the meaning of? A number of sensitive aircraft instrument and navigation devices which comprise some of the electrical loads may be disturbed and may need to restart or re-initialize following a power interruption. So why we need that power interruption should not be happen? You know that the aircrafts are having a lot of avionics equipments, navigation, communication, your display system, your electrical lighting, your generators, and all the things. These all are working with the help of the electrical power. If power is interrupted or the voltage or anything is not proper as per the design standard of the system, the power will create problem and system may not work as it's supposed to be working. So we need a parallel system that if anything happen, any one system fail, another should take over in very smoothly and aircraft should not be get disturbed. So that is the meaning of this second point. Third point, in order to satisfy this requirement, generators may be parallel to carry an equal proportion of the electrical load between them. Just now I told that we have two engines. I am writing here. These are the engine 1 and engine 2. Here we are fixing generator 1, G1, and this is the G2. So what is this? So in order to satisfy this requirement, means parallel, means aircraft interruption should not happen. Power should have very, very smooth, and our working electrical or electronics or avionics equipment should not be interrupted. So that power also should be in a very smooth and no interruption is permitted. So to have this satisfy requirement, generators may be parallel to carry an equal proportion of the electrical load between them. So these should have parallel and they should have carry the equal load. So it is divided in this. We can make this as a left and this is right hand. So this right hand side engine E2 will take all the loads of right side and the even engine will take all the loads of left side. So that type of situation, both engine and both the generator G1 and G2, they have to take the proper and balanced load, electrical load, and they have to share if one engine is failed. So another, the working engine or the working generator has to take the load of the the generator which is not working. So individual generators are controlled by means of the voltage regulator I have just described here. So here this voltage regulator, so individual generators are automatically compensated for variation. So individual generators are controlled by means of voltage regulators that automatically compensate for the variation. So if any fluctuation of the voltage, you know that if the voltage is going beyond some range, our system is going to burn. Our electrical system or the navigation or the communication or any avionics system is designed for a particular voltage. If the voltage is crossing that limit, that system is going to fail. So we should have some control devices like voltage regulator, which is automatically compensate for the variation of any extreme cases, and it maintains that the power generation is within the given and acceptable limit of the aircraft. There is a need to interlink the voltage regulator such that any unequal loading of the generators can be adjusted. So what happens now? If suppose this G1 has got the load of 100 amperes and this has got the 75 amperes. So they should also share between these two. So this 100 will give some load to this automatically, maybe 20 here. So this or 15. So this will be 90 and here this will be 85. So nearly same load they both have to share so that they are working very smoothly. Here DC generator parallel operation, it is shown here, which I was discussing. DC generator parallel operation. Here this you can see number 1 DC bus and this is the number 2 DC bus. Bus is nothing but a electrical power from where power is distributed to the different systems. Here we have the G1, here we have the G2. G2 means, G1 means first generator, FIR is first, FIR, first generator, and G2 is second generator. Second generator. Okay. So we have like this, we have. Now if you see here that the G1 from here, this goes to the, this is called equalizing coils. So from here, this goes here and these two are this one and this one. This and this. Two are the equalizing coil. This, the purpose of this coil is to make that the both systems are taking equal load. So these coils are for this purpose, and there is a voltage regulator. This is the voltage regulator, VR. Both sides, this will regulate the voltage, and as per the given condition, voltage will be supplied to the bus bar. So like this DC generator, parallel operation is ensured that if one is failed, suppose this system is failed, then what will happen? Now it is showing this side, this power, this coil will make that loads will be equally distributed, and this VR voltage regulator will make that aircraft gets a sufficient given voltage so that aircraft electronics and avionics equipments, electrical equipments, your this pilots instruments or this cockpit instruments, main all the systems has to work as per the required temperature. So like this, the DC generator, they are working parallelly, and we should ensure that they are doing proper work. Now third is there. I have just shown you here that we have here voltage regulation. So I have covered this. Now I will cover the third one. It is the protection function. Okay. So I am going to talk about the DC generator protection functions. How we can ensure that the safety of the generator or the power supply is safe. It is not hampering or it is not damaging the instrument which are fixed or which are running by this systems. So what are the protection system? First is the reverse current. Reverse current relays are there, and this is usually achieved by means of the reverse current circuit breaker or the relays. These devices effectively sense reverse current and switch the generator out of circuit, thus preventing any ensuing damage. So we might have seen that in our homes also, we have nowadays circuit breaker. These circuit breakers, if the current is trying to move in opposite direction, this will cut off. Okay, so here is this is the circuit breaker like this. So here some coils are there, and if the current is going in this direction, it is okay, and if you start like this, it will go up, and here circuit will be open. So like this, the aircraft safety is ensured. First one is the basic one is the reverse current relays, or it is called the circuit breakers. Next one is the over voltage protection. So if the current is like this reversing, then reverse current relays or circuit breakers are used. And if the voltage is over, then how we are going to handle voltage situation of this aircraft? Over voltage protection senses these failure conditions, and opens the line contactor, taking the generator offline. So over voltage protection senses these failure condition and open the line contactor, taking the generator offline. So if the voltage is up, they will make the system cut off and your system will be safe. Under voltage, if the voltage is less than the required, then it is called the under voltage, and under voltage protection capability is essential, as the equalizing circuit is always trying to raise the output of a lagging generator. In this situation, the under voltage protection is an integral part of the parallel load sharing function. So under voltage is also to control the under voltage is also very essential, and under voltage protection capability is essential, as the equalizing circuit is always trying to raise the output of a lagging generator. In this situation, the under voltage protection is an integral part of the parallel load sharing system. Next, voltage regulation I have discussed also in the previous also. It is AC generation control. Till now we have discussed about the direct current power generation control. Now we have the AC generation control, and this you have seen in my here itself, that in AC generation also we have the voltage regulation. Okay, this you can see, we have the voltage regulation, we have the parallel operation, it is same. Here we have the supervisory function. So this function will some additional things are here. Voltage and the parallel operation are almost same. So here I will be discussing about voltage regulation. First, the subject of alternating current generator excitation is a complex topic for which the technical solution vary according to whether the generator is variable frequency or constant frequency. Variable frequency, and here in AC we don't have the frequency system, but here we have the frequency. Okay, it is represented in hertz, means it is cycle per second. How much cycle per second it is moving. So this is always in the AC, not in DC. So the subject of AC generator excitation is a complex topic for which the technical solutions vary according to whether the generator is variable frequency or constant frequency. Variable frequency or constant frequency. Some of these solutions comprises sophisticated control loops with error detector, preamplifier and power amplifier. Preamplifier and power amplifier. So here we should have sophisticated control loop with error detector. So we should have some error detector. They should be able to detect the error. Then we should have preamplifier and the power amplifier. We should have preamplifier or the power amplifier. So these are the voltage regulation. It is not like a resistor. In this, we should have some more advanced systems. So that is called the error detectors, preamplifier, and the power amplifier. Now, in this, the second option, parallel operation, how the parallel operations are going to work. In alternating current generators are operated in parallel to provide no break power. This is for constant frequency AC generator only. This is for the constant generation AC power only. Okay. This is not possible in variable frequency AC generator. Few systems like anti-icing, de-icing, and frequency insensitive and no break power needed. So this is not possible in variable frequency AC generator. Few systems like anti-icing, de-icing are frequency insensitive and no break power needed. So like anti-icing and de-icing, break power is not required. It should be very smooth. It should always function. The generator output voltage depend upon the relevant performance of the voltage regulator and field excitation. Now I am talking about AC generator parallel operation diagram. So I have discussed, if you see here, I have discussed here, this is the DC generator. It is very simple. Only here we have the one coil, that is called equalizing coil, and here we have the resistance voltage regulator. Okay, so only these things are here. But if you see here, if you compare here, it is some very complicated comparing to the previous one. Here also we have the generator 1 and generator 2. From here it is going A, B, C. All the it may be the 3 phases. Error detection, we should always have one error detection. How much percentage of error it is giving. Means if it is a 220 volt plus and minus 20 volt. So this much are accepted. But if it is going 150 volt, then this will detect. And here also, this will detect. And this will give the feedback to the here trim. It will trim. It will increase or decrease the speed of the generator, and it will again balance the system. So here AC generator parallel operation. Here the CSD1 and here the CSD2, trim of CSD1. Okay. So here this you can see. Error detection here and error detection here also. This will go to this, and from here also this will go to this. Here also error detection to this and here detection to this. So both are how much variation of the speed is required. This will be find out by this error detection method. So I think it is very much clear. Now supervisory and protection function. In our DC system we have only the, if you see our DC system, we have only the protection function or protection system. But in AC, if you see, we have supervisory and protection functions. These are not, supervisory function is not there in our direct current system. Typical supervisory or protection function undertaken by a typical AC generator control unit or GCU are listed below. So these are the functions which the supervisory system has to undertake. They are over voltage regulator, under voltage regulation, under/over excitation, under/over frequency differential current protection. So in this, under voltage, over voltage, under and over both voltage at a time, under and over frequency differential current protection. So these are the issues which this protection system has to handle, because in our DC system we don't have this frequency variation. So there only voltage variation is there. Voltage variation can be handled by the voltage resistance method. So differential current protection is designed to detect a short circuit bus bar or feeder line fault which could impose a very high current demand on the short circuit phase. Differential current transformer sense the individual phase current at different parts of the system. These are connected so that detection circuitry will sense any gross difference in phase current resulting from a phase imbalance and disconnect the generator from the bus bar by tripping the generator control breaker. So if it feels that very high current is demanded or the very high voltage is there, so this will be given to the different systems, and this will make sure that the circuit breaker of that generator is cutting off the supply and the system is safe to work. So here I want to show some types of modern electrical power generation system, and in this you can see that CFM is constant frequency, IDG is integrated drive generator, VSFC is variable speed constant frequency generator, VF is a variable frequency, PMG is permanent magnetic generator. So we can see here that somewhere we want a constant frequency generator, somewhere we want a IDG integrated drive generator, somewhere we want a variable speed constant frequency generator, somewhere we want variable frequency PMG permanent magnetic generator. So this you can see here. If you see here, as per initial stage it was engine, here is a generator, and here we have constant frequency and integrated drive generator. Very simple generator, and these are normally providing 112 volt 3-phase 400 hertz. This is the power supply of this type of basic generators. Next is the constant frequency variable speed constant frequency generator. In this we have two types. One is called the cyclo converter and another is a DC link. So in this also, if you see, same type of voltage are supplied, but here it is a constant frequency and variable speed constant frequency. In this IDG is there, integrated drive generator. Integrated, it is fixed with the generator, but here the shaft will be moving and shaft will change its speed. Okay, so in this way we are getting, and this three type 1, 2 and 3. This three type of generators, that is the CF IDG, CF VS, CF cyclo converter, CF VS, CF DC link. They all are producing 115 volt DC 3-phase 400 hertz. So 400 hertz is very high frequency. If you see in our house, the frequency or in industrial use, we use the 50 hertz, not 400 hertz. So the advantage of 400 hertz is the fluctuation is reduced tremendously per unit time. It is like a very smooth current. It is not like alternating like this. It looks like a very smooth, so that 400 hertz are used in aircraft industry. Next is variable frequency. Here all are the constant frequency. Now if we want to change the frequency, here we are getting 400 hertz, but somewhere we can demand 380 to 700 hertz if we want. That time we have to use variable frequency generator. With the help of the engine control unit we can control, and this is supplying 115 volt 3-phase 380 to 760 hertz frequency. Next is here very new thing. This is the 270 volt DC generator. Now these generators are only used in aircraft of US origin, especially the modern fighter aircrafts. they have started using 270 volt direct current, and it is supplying 260 volt DC. Now the DC emergency power is also available. So in this, if battery and other systems are there, those are providing the 28 volt DC. Mostly battery is used for DC emergency use. Okay, so this we have to see that battery is also used, 27 volt DC is also used, and in this we are using the generator. Generator is making, but battery we are PMG, it is called permanent magnetic generator. Okay, PMG is permanent magnetic generator. This provide 228 volt DC only for the emergency purposes. Now I will talk about the constant frequency and IDG. Just you see this one, first one is the constant frequency IDG. This is the first one. So just I am going to explain about this constant frequency IDG system. So in this constant frequency, AC power is most commonly used on turbofan aircraft. Today, system is expensive to purchase and maintain, primarily due to complexity of the constant speed drive. Single company monopoly exists in this. If you see this diagram here, so here constant frequency, constant speed drive. So variable engine speed approximately 2:1, and this goes here, and in this system constant soft speed. This will always give a constant speed, but here variation of speed is there, but this generator will get a constant speed, and this is achieved by constant speed drive mechanism, which is and that is why it is very costly, and this gives an integrated drive generator. This is called integrated drive generator. This your drive is given here, and this system is making that a constant speed is achieved by some mechanism, and this mechanism is giving a constant speed to the generator, and it is supplying a constant frequency, 3-phase 115 volt AC and 400 hertz power supply. So this is about the constant frequency, how we achieve the constant frequency. But another thing is the variable frequency. In this is somewhat simpler. A simplest form of generator power, cheapest and most reliable variable frequency has impact upon other aircraft subsystems, motor controller may be needed for certain aircraft load. So here this you can see that a variable speed engine drive approximately 2:1 for turbofan. This gives direct. Here is no speed controller. Direct it gives, we get a variable frequency, 3-phase 115 volt AC, 300 to 720 hertz power. So this frequency will vary because here this speed is also varying. Speed is not constant. So this variable frequency we can get for different purposes. Next is a variable speed, constant frequency. Variable speed, constant frequency. So in this feature, conversion of variable frequency electrical power to constant frequency is accomplished by electronic controlled power switching. DC link and cyclo converter options are available. Not all implementations have proved to be robust and reliable. Cyclo converter shows most promising system. Okay, so this you can see here that variable speed, soft speed approximately 2:1. Variable speed, constant frequency VSCF generator, converter, constant frequency, 3-phase 115 volt AC, 400 hertz power. Okay, so this we can get a constant voltage and constant frequency. So variable speed but constant frequency. Here the speed is varying, but here we are getting by this converter. This converter will give us as we want the power supply. We want a constant frequency. We want a 3-phase 115 volt. We want 400 hertz. This device will give you, it is called converter, cyclo converter also. And this will supply a constant rating of whatever is required by the particular system. So now for the next class, I am going to discuss about primary power distribution of the system, power contactor, power conversion and energy storage, secondary power distribution, typical AC-DC system, electrical loads. So hope you have understood for the today's class, and this might have given some good idea about the system of electrical system, and you have seen that how this converters, cyclo converters are used to give the required constant amperes, constant your frequency, because that system want 400 hertz. So we cannot give 250 or 700. It will malfunction. To avoid that, we have to use a constant frequency converter, that is called variable speed constant frequency, VSCF converter. This will make sure that the aircraft is getting the required rating of voltage and the current and the frequency, and the system works very efficiently by this system. So in next class, I will be discussing about primary power distribution, power contractor, power conversion and energy storage, secondary power distribution, typical alternating current, DC current system, electrical loads. I am referring the references this, and I am taking my class by referring these books. That is the Moyer and Seabridge, Aircraft Systems, Mechanical, Electrical and Avionics System. And this is the Bury St. Edmunds, London. And another book which is the Design and Development of Aircraft System and Introduction, AIAA Education Series, AIAA 2004. These two books I am referring, and hope this will be very useful for you. I am also requesting, if any questions arising from your side, you are welcome to ask me in this email. My email is yddwivedhi@gmail.com. This is my email. You are welcome to ask questions related to the aircraft systems, aircraft maintenance. I will be very happy to respond to you. Thank you very much for joining the class, and please join for my next class. I will be going in detail about aircraft systems, electrical systems, then so many electrical parameters and electrical equipments, generators, their full detail I am going to discuss. Thank you very much for this.
Like, share and subscribe. Hit the bell icon for more updates.